somewhere beneath the tallest buildings on Earth, there is a war happening right now that almost nobody talks about. It is fought in total darkness, hundreds of feet underground, where the fate of every skyscraper is decided long before anyone admires. Its glass towers glinting in the sun. If that hidden battle is ever lost, the building above it, no matter how beautiful or expensive, is already doomed. And the strangest part is this. The most important piece of engineering in any super tall tower is a piece you will never actually see. When people stand at the foot of a skyscraper, they almost always look up. Engineers do the opposite. They look down into the ground. Because that is where the real question gets answered. Can this structure actually survive? A modern super tall tower can weigh more than several small mountains combined. Once you add up every ton of steel, glass, and concrete. And here is the unsettling truth. The ground underneath our cities is nowhere near as solid as we assume. Many of the world's greatest skylines are built on mud, loose sand, or soil that once sat at the bottom of an ancient sea. If the foundation is not strong enough, the structure can begin sinking. Sometimes just millimeters a year. That sounds harmless until you remember that in a building hundreds of meters tall, even a couple of centimeters of uneven sinking can be catastrophic. That is why, before construction begins, engineers drill dozens of boreholes to map the hidden geology beneath a city. Where the soil is weak, where solid rock begins, where groundwater waits to cause trouble. One overlooked detail can collapse a project worth billions of dollars. Many skyscrapers, in fact, are not resting on the ground at all. They are anchored into rock, buried dozens of meters below the surface. Foundations almost as deep as an entire mid-rise building, permanently swallowed by the earth. We imagine skyscrapers as a race toward the sky. But the real contest happens in the shadows beneath our feet. From a distance, a tower looks perfectly still, but its weight is constantly pressing the ground beneath it, deforming it bit by bit, every day, up to what engineers call the bearing capacity of the ground. In places like Dubai or Shanghai, the earth is so soft that raising a super tall tower is like balancing a giant needle on a bed of mud. New York, by contrast, sits on hard bedrock, close to the surface. An accident of geology that made it the birthplace of the skyscraper. But finding good rock is only half the battle. Because towers also fight enormous wind loads, pushing them sideways. A skyscraper is like a giant tree. The taller it grows, the deeper and stronger its roots need to be. That is why the foundation is often the most expensive part of a project. Even though nobody ever sees it. So, how deep does a foundation go? Before any tower rises, engineers dig an enormous pit downtown, so deep that standing at the bottom feels like staring out of an artificial canyon. That is nothing like digging an ordinary hole, since the surrounding soil constantly tries to cave in and crush everything inside. Engineers first build a diaphragm wall, a massive ring of reinforced concrete sunk deep into the earth to hold the soil back. Sometimes reaching deeper than the foundation itself. Once the soil is contained, giant rigs bore shafts dozens of meters straight down. The deeper crews dig, the more dangerous groundwater becomes. If water floods the excavation, the pit can turn into a lake of mud within hours. So engineers pump water out around the clock. Once a shaft is deep enough, workers lower massive steel cages into it to form the skeleton of a pile. Then fill it with concrete. Some super tall towers need hundreds, even thousands, of these piles to spread that colossal load into the deep ground. Remarkably, the underground phase sometimes takes longer than building the visible tower above it. And if the foundation is off by even a few centimeters, the whole structure can end up permanently tilted. Which is why engineers monitor every tremor, almost like tracking a patient's heartbeat. Hundreds of enormous piles can be buried beneath a single skyscraper like a forest of steel roots. Some individual piles longer than the Statue of Liberty is tall. The entire weight of a tower, its steel, glass, occupants, and every storm that hits it, travels down through those piles in a process engineers call load transfer. Piles keep a building upright in two main ways: gripping the soil through friction or driving down into solid bedrock. Where the ground is soft, engineers drill far deeper to reach a strong layer. And sometimes rock sits so deep that reaching it is barely realistic. So the structure ends up essentially floating on friction alone. The Burj Khalifa relies on hundreds of piles cutting through scorching desert. Sand to reach stable ground far below. Weight is not the only enemy. The higher a tower climbs, the more wind pulls it sideways, forcing the foundation to act like a giant anchor holding a steel ship steady in a storm. Despite looking solid as stone, most skyscrapers sway slightly every day. In strong winds, the top can shift several dozen centimeters, while the foundation keeps the structure inside a safe limit. Engineers calculate uneven settling between piles down to the millimeter, because if one section sinks faster than the rest, the tower can begin tilting permanently, sometimes so slowly nobody notices until it is too late. How do these giants survive earthquakes? High up, wind alone can turn a tower into a constantly trembling structure. And if that motion goes beyond safe limits, people inside can feel dizzy or panicked, which is why towers are designed to bend and absorb force. Almost like a living body. An earthquake is worse, shaking the ground violently within seconds, attacking directly from below, right where the foundation is trying hardest to hold everything together. Japan has turned its tall buildings into some of the most earthquake-resilient machines on the planet. Many sit on massive damping systems that absorb shock waves the way a car's suspension absorbs bumps. And some even contain steel spheres weighing hundreds of tons, suspended inside to swing opposite the sway and cancel out dangerous vibration. Where earthquakes are most powerful, damping alone is not enough. So, engineers developed base isolation, letting thousands of tons of concrete and steel essentially float on giant, cushioning layers instead of standing rigid. Thanks to this, buildings have survived quakes powerful enough to have leveled entire cities decades earlier. Even so, every technology has limits. If resonance occurs, when a structure's natural vibration rhythm matches that of the wind or quake, swaying can spiral out of control. Which is why every super tall tower undergoes countless simulations and stress tests before it is allowed to rise. What hidden structures sit beneath the world's most famous towers? The Burj Khalifa does not rest on a slab of concrete. It is held up by hundreds of piles driven through scorching sand into stable layers below. Shanghai sits on soft river sediment, so its towers risk sinking over time unless the foundation is calculated to the millimeter, requiring extremely deep systems and complex load distribution technology. New York has hard granite bedrock close to the surface, letting towers anchor directly into solid rock. A big reason the city became a birthplace of the skyscraper. Not every super tower rises on dry land either. On artificial islands, foundations must withstand seawater, waves, currents, and decades of corrosion at once. And in some offshore projects, the underwater portion is actually larger than everything visible above the waterline, whether on desert sand, soft soil, or open ocean. Every super tall tower shares one thing. The foundation is usually the most expensive part of the project. Even with unlimited money and the most advanced technology, foundations can still fail in ways nobody predicted. A small shift in the soil, enough to send a tower leaning. so slowly that no one notices right away. That is the moment people realize the most dangerous part of a skyscraper is sometimes not at the top, but buried in the darkness below. History shows that once a foundation starts to fail, buildings rarely collapse suddenly. They lean quietly, year after year, before anyone recognizes the danger. One famous case is the Millennium Tower in San Francisco. Once celebrated as a symbol of modern engineering, before residents discovered it was steadily sinking and leaning to one side. What made it so unsettling was that the cause was not a dramatic event, but the slow, quiet shifting of soil deep beneath a busy city. In many cities, the ground itself sinks slightly every year from groundwater extraction and the sheer weight of concrete pressing down, compressing soft soil until neighborhoods sink like a deflating cushion. Even a few centimeters of uneven settling can create dangerous, twisting forces throughout a tower. Repairing the foundation of a super-tall tower is a bit like performing heart surgery on a patient who is still standing and moving. Engineers sometimes dig directly beneath an occupied building to install new piles, using massive hydraulic jacks to lift a section by millimeters to rebalance the structure. But the more repairs happen, the greater the risk of new shifts, turning it into a battle that can drag on for years. And some buildings have even been demolished because saving the foundation cost more than the tower was worth. Sometimes the danger is almost invisible, like vibration from subway trains or nearby construction. Tiny tremors, repeated for decades, that reshape the soil in ways engineers struggle to predict. That is why so many towers today carry thousands of sensors tracking the smallest movement in their foundations, behaving a little like living organisms, sensing the ground before danger becomes visible. How far will foundation technology need to evolve? Future engineers are no longer just designing foundations for individual towers. They are planning underground cities beneath modern metropolises, with layers of transportation, data centers, and power systems running round the clock. The deeper humans dig, the more they face crushing pressure from rock, groundwater, and rising heat. So tomorrow's materials may need to be stronger than today's steel yet. Flexible enough to withstand constant vibration. Some technologies already explore self-healing concrete that seals small cracks before they become a disaster. And robots may eventually take over much of the dangerous work of building deep underground. The biggest ambition remains towers taller than a kilometer, requiring foundations that spread wider and deeper than several city blocks combined. Some engineers believe the real limit of the skyscraper has nothing to do with height. and everything to do with whether the ground below can bear that weight. But the deeper we dig, the closer we come to hazards nature has kept buried for millions of years. Beneath busy streets lies a vast underground world most people will never see. Thousands of kilometers of tunnels, subway lines, and cables crossing one another. An artificial labyrinth so complex that even engineers struggle to picture it whole. The more we build, the more hidden voids we accidentally create. And sometimes those voids trigger a sinkhole. When the ground loses stability or water quietly washes soil away over years, and the surface above collapses in seconds. Some sinkholes are no larger than a manhole cover, while others have swallowed buses or entire sections of a building at once. That is why engineers keep monitoring the ground for decades after a building is finished. What would actually happen if a super tall tower's foundation failed completely? At first, almost nothing would look unusual, since towers are designed to redistribute load. A bit like one leg of a table growing weak while the others take on more weight. But in a structure hundreds of meters tall, that process is far more dangerous. Twisting and deforming the whole structure, forcing columns, floors, and the load-bearing frame to work beyond their limits just to keep standing. Upper floors would start shifting, glass could crack, and systems would destabilize. Usually very slowly, until the structure edges toward a critical breaking point. When load suddenly shifts onto the remaining areas, triggering a domino effect where one failed column drags down others. Modern towers are built with layers of protection engineers call redundancy. So if one section fails, other parts can temporarily take over. But if the ground beneath becomes unstable on a large scale, even the strongest backups can be pushed past their limits. In extremely powerful earthquakes, soft soil can behave almost like liquid, a phenomenon called soil liquefaction, where foundation piles lose their grip entirely, leaving a tower standing on what feels like liquid mud. That is why modern cities build sensor and early warning networks, tracking vibration and ground movement continuously, almost as though the city is running a constant health check on itself. In the end, the greatest cities on this planet depend on something almost invisible, buried deep beneath their own feet. We assume a skyscraper's strength lies in how high it reaches into the sky. But the truth is exactly the opposite. What actually determines whether a super tall tower survives for centuries lies hidden. In the darkness, far beneath it, those blocks of concrete and steel that are the real roots of our modern urban civilization. Without them, cities could never rise, and the world today would look completely different. The higher we build, the clearer it becomes that the real battle was never with the sky. It has always been with gravity and the earth beneath our feet. The future of our megacities may be even more extreme, with projects already dreaming of towers rising several kilometers into the sky, where the foundation alone could be as wide as an entire city block. But the bigger we build, the clearer the limits of our planet become. Because every structure has to hand its entire weight over to the ground beneath it. Perhaps, far in the future, humanity will have to choose between building ever higher or expanding civilization downward into the earth instead, until the underground becomes home to millions, with subterranean cities larger than anything visible on the surface today. Those enormous foundations would no longer simply hold buildings upright. They would become the true skeleton of an entire future world. Because, in the end, the greatest secret of the skyscraper was never its height. It was always the part hidden beneath our feet, the part we were never meant to see.